Hi, in this lesson, I want us to try and tackle the radon study task. We've already seen that radon is a significant geomedical hazard, but what can be done about it? Let's have a look at some of these questions. You will need the radon study task sheet. Let's go. So the first couple of questions are about the geography of this, where this occurs. Um, you have maps here of southwest England. This is the real hotspot for radon gas problems in the UK. We need to describe and explain the areas of higher radon gas concentration, and also perhaps try and link that to the geology. The second part of this task then is to look at the um, occurrence of radon in different geological settings. So we've got a cavern there in limestone, location A. Why is there a high concentration of radon in that particular location? Think about where it's moving, how it's moving. As well as subsurface geology, we also have drift geology that can have an influence as well. We've got different concentrations of radon in different buildings here, depending on the subsurface geology. So can we explain the effect of the clay and the sand and gravel on this? Okay, those are the questions. Have a go at those. Now's the time to press pause. Okay, let's have a look at some answers to these questions. So the first question was to describe and explain the distribution of high radon concentrations in southwest England. Okay, 3 marks for this. Now these marks, you need to have one descriptive term or one description. You need to have one explanation and then one other. Make sure you're hitting all of these things. If you've got 3 explanations, you're going to end up with 2 marks. Okay, let's start with the description. Sometimes just stating the obvious can get you marks. There are 3 main areas, for example. There's also an area of moderate concentration in the north of this map. You could talk about the associated rocket ages. So, this is in these areas are within the, or generally within the Devonian, possibly Carboniferous rocks. And the fact it's associated with the granites. The 3 high spots there are all above areas of granite intrusion, which is no coincidence. If you look at the explanations then, granite is rich in uranium as a source of this material. Uranium, we know, decays to radium, which decays to radon gas. It's a radioactive breakdown product. And if you haven't already mentioned it's because it's associated with the granite. Okay, so you need one from the column on the left, one from the column on the right, and one other for those 3 marks. Okay, if you look at part 2 then, why radon is hazardous? Well, it causes lung cancer, or you could say it's poisonous, it's toxic, it's cancerous. Any of those ideas will get you marks. So then if we start looking at the subsurface geology of this, So we've got this limestone cavern. If you look at the sort of annotations that you need to put, when this was set as an exam, there was a reserved mark. Okay, the fact that gas is in solution in the groundwater is a reserved mark, or and there's lower pressure in the cave. So as the water flows into the cave, pressure is released and the gas can come out of solution. You need one of those two marks to get full marks for this question. We still need to pick up some other marks though. So extra marks can be picked up by saying, the groundwater is clearly flowing down that fault zone or through the fractured rock there. We can see above the granite and along the fault. We've also got a pathway from the joints and the bedding of the limestone to allow that water to move. Okay, the second part of the question asks you to look at the drift deposits, the superficial geology. Let's think about the clay first of all. So the clay is impermeable because the pores are incredibly small within clay and they're not connected. There'll be few fractures or joints within this material. Okay. Any three of those will get you marks, or you could have two of these and pick up 3 on the sand and gravel. It just depends. If you're giving this as an answer in an exam question, I'd be not trying to limit my answer. I'd be trying to make sure I'd nailed it properly. For the sand and gravel then, it's permeable. We've got high porosity here. There would be much larger pores within the sand and gravel. It's not cemented together. It's a drift or superficial deposit. These pores are likely to be interconnected. And particularly if that sediment is well sorted, or certainly if it's well rounded, there will be pore space. It will be permeable. Again, any 2 or 3 of those is going to get you the marks. So, as we look at the sunset from Land's End in Cornwall here, and we see conclusions in Cornish, there we go, let's sort that out. We can see that radon concentrations and geology, whether that's on a large scale in terms of major subsurface features like granite plutons, or on a much smaller scale, like what the surface superficial deposits might be, has a major impact on the risk posed on a property from radon gas. In assessing the risks of radon gas for your own property, it's really important to understand what's below you.